says.
I just didn't want to say it out loud again.
Again, it gets tiring, but.
Well, good afternoon, everyone. Thanks for joining us again for the Forever Green Initiative research updates and discussion. And I think over the last few weeks, we've had great updates, and the part that I like the most is the discussion that's been occurring at each event. So that's the overall intention of these meetings. So as you all know, before we get started, we usually have a chance to get started at about 12:05, and prior to that, we always open it up for any announcements, updates, comments that you might want to share with the group. So let's go ahead and open it up at this stage for any input from anyone in the group. It's online or here in 408.
I'll just reiterate what I said in my email the other day, which is next week, our last meeting of the semester. I'm hoping we can get people in this room and to see each other face to face and do our usual thing, but also have another half hour or so at the end to just hang out and catch up. And we are working on getting some Forever Green goodies pulled together for the group. So look forward to that. And obviously, within the bounds of safety and health, we would love to see everyone.
Yeah, thank you very much. Do you have a few comments you want to make in terms of the development of the restructuring the FGI program and what's happened at the first meeting and there's another meeting today? Could you just give them a brief update?
Sure. Yeah. So I think Don, you're referring to the executive committee.
Yeah, all right.
So I've been meaning to send a recap of our first executive committee meeting, and getting the list right is the blocker because we have such a big diverse group of people. But we had our first executive committee meeting about 3 weeks ago. Recall that this group was elected by the active research faculty here at the U within Forever Green, and there are 6 of those folks, in addition to Don, Nick, Colin, and myself sitting on that committee. And really the first meeting was kind of setting the stage. We spent a long time looking at the very complex org chart of Forever Green and all of our partnerships. So not the most just exciting, but useful information. And then we started to get into, okay, what are some of the big decisions that we're going to need to make as a group? And what I'm hoping to do in our next meeting, which is coming up soon, I believe it's actually next week, but that is to start to narrow down that list of priorities, because it takes a lot to bring a group of busy people together. So our time together is going to be pretty limited. So getting a focus on our priorities, and then also having some discussions about how exactly we'll work together, how the elected advisors relate to the people like me and Colin and Don and Nick, who kind of do this as a job. What that relationship is going to look like, and how decisions get made and kind of delegation of authority and that sort of thing. So it's really all adding up to an evolution of the leadership structure for Forever Green that hopefully puts us on sound footing to move forward into the future and continue to be successful with a model that can deal with people leaving, new people coming in, and being adaptive and flexible throughout all of that. Anything else you want to?
No, I think that's fine, just to make sure everyone knows that is ongoing.
Mhm.
And it will continue to develop. And we'll try to figure out a way to keep everybody outside of the core group updated, and we'll have to work through that.
Yeah.
Other than just making announcements
Yes.
here. So any other comments from anyone in the room or online for today? If not, I'd like to turn it over to Neil Anderson. And he will represent the group and that's working on perennial flax. And he'll lead the update from the perennial flax team. Neil, it's yours.
Welcome, everyone. So we had fun putting together our kind of sum total of activities for perennial flax this year, and various people will be interjecting and chatting about their sections as we come to it. Just remember that you have your microphone on when you do that. So that'll involve Hannah and Liz and Kevin, and then Carrie. And then, of course, we'll be happy to take questions along the way. And so without further ado, just kind of an update on where we're at. We have a couple new pubs that are out in perennial flax. Another one just got accepted into agronomy on our herbaceous perennial crop idiotype. That just got accepted today. And so, we continue to churn out publications. We have, tons more obviously to work on. Hannah will be defending her thesis next February probably, and so she'll have many publications. Then of course Liz will be generating more, and all the work that Kevin's working on with the IR4 registration for herbicides and our harvesting techniques, etc., that we're trying to refine will all be upcoming publications, obviously, for the perennial flax group. And where we're at least as funding sources or streams for the project, are as follows. We have finished our USDA crop germplasm committee grant that we had, but so right now we have an MDA grant on cut flower, perennial flax that Liz is involved with, and several other people. We have a new LCCMR grant that started in July. I'll mention that towards the end. We're not going to actually present any data from it yet. That will be in our next talk next year on that. And then we have a couple upcoming either funded or pending grants involving perennial flax listed here. So Hannah, why don't you jump right in and talk about some of the work you've been doing with SNP, work with our flax species for the USDA grant, as well as for the breeding program.
Yeah, hi everybody. So I'm Hannah, and what I've been focusing on most recently is that we got all of our data back from DartSeek all the way in Australia. And so I've been analyzing all of that information that we were able to get from our nearly 1,700 samples. And so what we are doing is we are trying to figure out the relation between all the different GRIN samples, and then also figure out if any of the GRIN species have any potential like mislabeling or miscategorization as far as species goes. But we're also analyzing all the SNPs to see if there are any, so that we can better select for traits. And so this is kind of just the example of how we took all those samples and prepped them and sent them off to diversity array. Next slide. And so based off of what we've been able to analyze so far, we have our top perennial candidate species that we've held a lot of interest in the past, but then now that we have all this genetic information, we're really wanting to refocus on them for our program. And so those species are Linum austriacum, Linum lewisii, and then Linum peren. And so these species all based off of our qualitative data we've seen that they have really long quantitative and qualitative data, that they have high yields, high germination rates, large flowers, and long flowering periods. And all these different qualities kind of make them well selected for our different idiotypes, which we are selecting for oilseed, cut flower, and different garden ornamental types. All right, next slide. And so we're looking at the SNP markers. So for example, here we have our top perennial species. And so we've been trying to see what the call rate for all of our different samples are, and we have a call rate of 0.90. And so you can see our the pre-filter and then after post-filter call rate for all the different loci. And then we take those that meet the threshold, and we are able to run different statistical analyses. Most importantly, though, we are able to put them through structure. And so this can help us pinpoint how many different populations we can observe amongst our samples. And so this is all how all their variation and their genetic relatedness is. Right. Next. And so what we mostly saw is we saw with the K value of 2. So that means there are 2 very distinct populations amongst the entirety of the 3 different species that we analyzed together. But if you look at it even closer, you can also see around 4 smaller groupings amongst our samples in our populations. So that's very interesting, and we're really wanting to take a look with even more species, all of the grid species, also in reference to our own breeding stock that we took samples of and have been upkeeping, and then also looking at them in different groupings of species to kind of pinpoint whether or not the different phylogenetic trees that we've been able to find kind of are supported by our genetic data. All right, next.
And I'll add in too there that you can see like there's a little Austriacum dot way up here. And some Austriacums over here. And so once we add in the genotype information, we may see that, this is actually a mislabeling probably here in USDA GRIN or in the Canadian system or something, as well as over these, are these all hybrids or are they all mislabels or what? So that's going to be, a next series of analyses important for the breeding.
What's your thoughts about the 2 pools for Perennial?
Well, so you'll see in the next few slides that every one of the species, when you analyze them separately, has 2 separate pools.
I see.
And we don't know if some of those are mislabeled or
I
interspecific hybrids. So
Yeah.
we'd have to go in and key out what the phenotypic data looks like. So and we knew that we had a kind of a mixture in our breeding populations. And so now it's like, yeah, we sure do. And so we're gonna have to go in and sort them out specifically, So
Linum austriacum, as you can see, as you saw in the previous slide also, that it has 2 very distinct groups. And then
you can't see it on the slide, but that's 1,199 SNPs. Specific to Austriacum.
And next slide. And so for Linum lewisii, we were able to call back about 90 SNPs, and also has 2 very, very distinct groupings, though the one on the right is kind of very separated amongst certain portions. So possibly if we were to look at it closer, maybe there would be more groups, or in relation to other species, there could be more groupings. Who knows? Next slide.
We have a small sample of Louisiana, and so if we added in more, we don't know what else we'd find in. And of course, we haven't yet seen what those genotypes on the left mean. Are they very distinct population or not, or what? We have no idea. So I mean, that's,
or they could just be mislabeled.
they could be mislabeled as well.
Could be mislabeled.
right, so.
If we also were able to put in more species that kind of also follow the same grouping trends, there may also be some interspecific hybrids amongst them between the groups, between the species. So that may also account for some of the variation within the group on the right.
And so, of course, one of the things that we look forward to doing in the future is getting those that we think are pure species and making interspecific hybrids and seeing where those fall in relationship to these outlier groups.
Yeah, and Lynn Peren, we were able to find like 2,716 different SNPs. And once again, you also have the two distinct groups with the group on the left having a lot of variation in the similar way that Wyse also had. And next slide. And so what we were able to conclude is that perennial flax species are distinct, although the perennial ones that we did analyze, we showed you today, have quite a bit of overlap. And that also may mean that there is some misidentification amongst those different species. And so there tends to be two distinct groupings within each of the species, and the AMOVAs show significant variations within and among the different species populations. And so there may be some interspecific hybridization amongst these species clusters. And then also we are interested in looking at how the different phenotypic traits match up with the potential hybridization hypothesis. Future SNP analyses of all the other different species that we do have samples of will help to clarify why these groupings cluster in the way that they do. And then our SNP discovery will also allow for greater clarification of the genetic structure of flax in general, while also allowing us to be a lot more selective in our breeding efforts, so that we can pinpoint the different traits for our genotype breeding. So these are all of the different species that we got from USDA GRIN, and so we have a lot to look at. And this is not also including our own breeding stock that we took samples of, that we have kind of selected for different things such as oilseed, cut flower, and then also the flower holding potential as well. So we're very interested in seeing how the GRIN species accessions kind of match up or compare to our own breeding stock that we have here at the U.
So basically Hannah's running tons of structures on every computer we have.
Yeah, yeah. I'm kind of monopolizing them right now, so.
All these analyzed, right? So
You know, why do you, this is the example of a really high level of mislabeling potentially that I've
Correct.
ever seen.
correct.
Why do you think that is?
Well, yeah, I mean, oftentimes, the collector might go out there and think
Yeah.
that it's this
Yeah.
and write it down, and then maybe they never do grow outs, or when they do grow outs, they don't actually have a taxonomist key it out.
Yeah.
And also GRIN tends to be a little slow on updating databases,
I see.
because we ran into that with our chrysanthemum arcticum collections that are housed in Ohio. And they had sent us some samples they had. We trialed them for 3 years, determined they were a different species, sent them all the data. They've never updated GRIN.
No.
It's just like, well, okay, I guess they're overworked. So, so there's many reasons why this happens. And the problem is it just keeps perpetuating. Hopefully they'll get fixed someday, but I don't know.
Is there also a question if all of these are really genuine species or if they're very slight differences, but
An additional question, absolutely, right. yet to be determined, right? So.
And in the chat, Les Everett asked if there are interspecific crossing barriers.
So
Well,
based off our
Go ahead, Hannah.
past research, the linum species can be kind of separated out into these different gene pools. So gene pool 1 has the generally cultivated flax and linum bienni, which we have samples of. And then when you get further and further down into gene pools 2, 3, and 4, the barriers to crossing get a lot greater. So generally gene pools 2 will tend to cross, possibly producing sterile offspring. And then once you get down to gene pool 3, you are not seeing really any interspecific hybridization amongst those different species in gene pool 3. And once you get down to gene pool 4, those are ones that have to go through some form of genetic manipulation or other fancy stuff to force hybridization.
Okay, thanks, Hannah. Let's jump
Thank
in
you.
now with Liz.
Hey everyone, thanks Hannah. My name is Elizabeth Goodman. This is about my first year on the grant, so I'll just jump right into it. And I can segue by saying once we have a little more information on all those SNPs from Hannah's work, I'll have a little more information on the cut flower gene pool I'm dealing with, because it's likely a combination of those 3, L. peren, Austriacum, and Lewisii. So we'll find out. So overall, my research focus is to test 15 advanced selections of perennial flax for their production, post-harvest, and distribution potential as a new blue cut flower crop. Objectives under that would be to determine how to propagate it, how to produce it, best management practices for harvesting, post-harvest methods. Also just overall developing the phenotype that we want based on the cut flower idiotype. Which means we want to maximize bloom longevity and find out how they perform in the field versus the greenhouse. And lastly, to convey that research to stakeholders through different types of extension events. Next slide, please. So trials at these sites, or 7 different sites statewide, over the next 2 to 3 years will provide valuable data on the phenotypic response to environment and the performance in different systems. The top 5 genotypes are being grown at all 7 sites, while only Rosemount and St. Paul will grow all 15 of the selections. Post-harvest trials are only occurring at Kohler and Dram Wholesale, which we'll talk about in a moment. Their expertise on commercial flower storage has been very useful so far to trials. And I have a ton of data from all of these sites from this past season that I still have yet to plug in. I'm looking forward to seeing what the numbers say. Just kind of an overview of things. Next slide, please. First objective, establishing propagation protocols, production timelines, and quantifying the yield of cuttings per plant in a greenhouse production environment. This picture is of the propagation and production trial currently underway at St. Paul, where we've grown out rooted cuttings of all 15 genotypes and rated rooting success of each. They were grown on in 2 different container sizes, and weekly cuttings were taken from each plant to quantify how many new plants each stock plant might produce. This trial will give us the productivity per genotype on both pinched and unpinched stock plants grown at different densities with 1, 2, or 3 plants per pot. So we're testing a few different factors there. Next slide, please. So this is just a photo of after 16 weeks of growth and weekly cuttings taken. So far, we have an average of about 2 cuttings per plant per week. So about 23 cuttings per plant in 3 months. Rooting between pinched and unpinched was not significantly different, but you could see on the right side maybe that the pinched plants had slightly more roots, as you can kind of see it, but it was kind of an informal observation just to see how they responded. And this is of 3 plants per pot in a 1-gallon pot as an example. Above is cut flower type 2 and below is number 13. So those are my 2 types with the longest holding potential. I just wanted to see what they did in the pots after a few weeks. So we'll continue weekly cuttings after these plants have completed their 6-week vernalization period to then see how they'll perform with or without a plant growth regulator such as Florel, which induces lateral growth and branching. So we'll see if maybe they'll be more productive after they have their cold spell. So that's currently where they're at. Next slide, please. So just to quickly look at some of the root ratings, all cut flower types have shown a 65 to 100% rooting success. As most of us probably know, they're easily vegetatively propagated. 4 types, 3, 6, 7, and 13 show 100% rooting success. While type 12 was the lowest at 65. You can see it had a lot of that blue, a lot of those 0 ratings were not very great. Success was a rating of a 2 or greater. So it might have little tiny roots or a root callus, but after 3 weeks, if that's all it has, I rated it as successful if it's a 2 or greater. And most of them did pretty well. Let's see, most types can root within 2 weeks, but 3 is much, much better. So just a quick overview. Next slide, please. So some genotypes are faster and more robust when rooting, and I found that hygienic propagation protocols are definitely necessary to reduce losses due to things like bacterial plugging in the bottom of the cutting. Pictured here are types 2 and 8, 2 on the left and 8 on the right. Their rooting performance was not reflected in their field performance, as the poor rooting cut flower 2 type on the left has one of the longest holding blooms and no rust issues in the field. So I initially thought number 2 is maybe not that great. Turns out it's a really great holding potential in the field all day. And number 8 on the right, super robust rooter, but in the field it has weak stems and intermediate rust susceptibility. So again, the phenotypic plasticity and just the specific genotypes acting differently this is why we're doing this, to find out how they're going to act. So next slide, please. So with 7 different locations, of course, we need to determine the scheduling, the plant spacing, the flowering time, and then the cut stem yield per plant and flowers per stem. Of course, collecting data from a range of growing environments will give us a lot of information on how the plant performance and yield might differ across locations. Pictured above are the 2 greenhouse production trials at Len Bush Roses in Plymouth and at the plant growth facility here in St. Paul on the right. Greenhouse production at Len Bush in the same cultural conditions as Asiatic lilies proved to be a challenge for flax, as they were 2 plants per crate in coconut core versus regular potting mix or field soil. So we will be adjusting those conditions when restarting this trial in the spring. The other 2 sites are in Morris and Grand Rapids. And like I mentioned, I'm just starting to enter data for all of these sites from the past season, looking forward to seeing those numbers. Below left is Rosemount, where the majority of the plants are. The bottom middle is Houston, Minnesota at Sweet 16 Farm, the only pseudo-organic or non-conventional production trial site we have. And the landscape fabric has proven to be very helpful with the weed control, since that's really the biggest challenge with flax production. And then of course, bottom right is at St. Paul, where we have all 15 types trialed as well. Next slide, please. So one of the post-harvest trials that we just completed is the Wyse Life trial, testing the testing the effects of light and dark in cold storage. So let's see here. So this is a cold room, kind of simulating a walk-in cooler that a florist might use. So over 9 different trials in the past 6 months, we've trialed all 15 genotypes in 3 different Wyse solutions, and for 2 weeks per trial. Daily data was collected on the individual bloom longevity and the number of days each bloom lasted. Again, data analysis for these trials is currently underway, but it was somewhat clear, if we go to the next slide. Thank you. That based on some of the preliminary data, a lot of the dark storage was consistently holding more blooms than the light. These photos are the last two trials, 8 and 9, showing all 144 stems per trial, split between the light or the dark treatments. These show consistently longer base life and bloom retention in the dark treatments, though of course, data analysis is not complete. It was also observed that the earlier opening blooms lasted longer than blooms opening later in the trial, with some blooms lasting up to a week or more. So in other words, if something opened on day 3, it might last a week, but if something opened on day 10, it might last 2 days. So very interesting so far, and I'm looking forward to crunching those numbers. Next slide, please. Conversely, these are the same 144 stems after 2 weeks of cold storage in either light or dark, and then a few days up to a week of room temperature base life. So after I had them in the cold for 2 weeks, now how are they going to act at room temp? Observationally, we see that the dark storage delays flower opening and senescence, but light storage may provide more photosynthate for room temperature growth and floral development once removed from cold storage. So we just saw that the previous photos, we saw that the dark storage had more blooms while in cold storage. But once we take them out, we now see that the light storage is profusely blooming while the dark storage has that chlorotic growth. Most of the blooms are kind of done. So it's just interesting to see this so far, and we'll explore it further. Next slide, please. Another quick post-harvest goal that we have not started yet, but will, is to find if ethylene inhibitors influence bloom longevity and whether those are transitory effects or not, as found in previous trials. Since the flower drop in the cut flower perennial flax is the biggest challenge, we want to see what can help them hold their blooms longer. So we intend to test both 1-MCP and AVG on petal abscission, while also testing other either wet or dry storage. So some flowers can be stored dry, like carnations, they don't need water. Flax has shown to be able to still flower in dry as well. So wet or dry storage with ethylene inhibitors to see what happens with that. We'll also be testing how the preservatives melatonin and chitosan affect vase life and bloom retention. They have some antioxidant properties. So we'll see about those in the future as well. Next slide, please. So another objective, assessing the bunching and sleeving methods for longevity of these bunches in commercial coolers. We need to determine which combinations provide the greatest longevity in these commercial settings to help establish industry standards, and this will also help inform producers and wholesalers how to best store and transport these bunches once they've been harvested. So once the stems have been harvested and prepped, like the leaves have been stripped from the bottom and there's a fresh cut, these stems last for weeks in the cooler. So we'd like to test how many stems per bunch might be ideal for this. Next slide, please. Post-harvest trials for this at Kohler and Dram have begun, and we recently trialed single-tied bunches in either a standard cold cooler, which is on the left, or a tropical cooler on the right. And these trials were also 2 weeks long, just like the light dark trials. So I'd have a basis of comparison. We found that stems in the tropical or 55-degree cooler on the right continued growing at a pretty great rate and had many more flowers open than stems in the conventional 30-degree cooler on the left, which is to be expected. Interestingly enough, the number of flowers that opened also differed greatly among genotypes. So if we go to the next slide, we can look at that as well. So in the yellow is the warmer cooler, 12.5C. We could see that it logically encouraged more growth, and thus more flowers were observed. Cut flower types 1, 3, 6, and 7 had the greatest number of flowers at this temperature. And then the standard color in blue, the negative 1.1C, logically had less flowers open, and results among the genotypes were not as variable as in the warmer cooler. At this temp, cut flowers 1, 2, 5, and 6 had the greatest number of flowers. So that was interesting as well. And we will be doing more of those next season as well with Kohler and Dram, once we have field growth again. Next slide, please. So last objective is to convey the research findings to stakeholders through community and online research, or online outreach, excuse me, and share research outcomes. Organizations such as the Association of Specialty Cut Flower Growers and small-scale farmer florists like Sweet 16 Farm on the right here are some of those stakeholders. This is Sarah Joy on the right. She's owner of Sweet 16 Farm down in Houston, and she's one of over 2,500 North American specialty cut flower growers. So between here in Canada and Mexico. Here she's just showing us how she likes using flax for that pop of blue color in an arrangement. So I just wanted to share that. And the floral design events also include things at events at places like Kohler and Dram. So if we go to the next slide, we can look at that as well. So Kohler and Dram and their Institute of Floristry is another of those stakeholders, a local wholesaler interested in trialing a new blue filler product, filler flower. Recently, some of their floral design classes tried the top 5 cut flower selections in some designs, and they also completed user surveys afterwards. Many people enjoyed the flower color, length of stem, and using the dried seeded stems in designs like these wrist and lapel corsages they gave me when they were finished, pictured on the left here. I could kind of make out some of the flax seed bowls on the right where Neil's pointing. They're pretty cute. And more design events and surveys will be upcoming next season as well. We're also going to trial some of the dried stems in the floral design class this spring. All right, next slide, please. This is just some early survey results incoming from Kohler and Dram Institute of Floristry on just 2 of the 14 questions that we asked. We could see that most people enjoy the flower color and the textural interest of the seeded foliage and stems. Some thought it was versatile and easy to use. Flower drop is considered here as well, and some responses state they'd still purchase perennial flax for cut flower use if petals drop daily. So that's about all I have for now for this update. It's been a whirlwind 10 months, but amazing and fun learning about this wonderful plant. So thank you. Welcome questions if you have them.
Okay, thanks, Liz. I don't see any questions online, I guess. Or there's one here for
I
you.
have
Sorry.
one
Go ahead.
question.
Two.
You
Go ahead.
mentioned melatonin. I was curious about that. What? Or maybe I misheard you. You were talking about.
No, that's right. Melatonin. Right.
No, you heard
Answer that, Liz.
correctly. Yes, you heard correctly. Melatonin, the stuff that helps us sleep at night. It might be in a different form. I'm not a biochemist. I'm not sure, but Cindy Tong is a post-harvest specialist, and she is going to help write that trial SOP. I think we'll be starting in January. So I think melatonin has some antioxidant properties that helps delay petal abscission, but I'm not sure on all the inner workings. That's about all I know so far.
It's a new paper that just came out, and we were shocked as well because we were going to try other standard compounds, anti-ethylene compounds, and then it was like melatonin. What the heck? Okay, let's try it. So we'll see if it has an effect or not. Did you have a
Link to
question?
the picture.
One more question, Liz.
Hi Liz, this is Jess. I was wondering, I was curious about your mention, I know this whole project is about the cut flowers, but I was curious about your mention about the foliage and the textural interest. And because I at least find flax to be quite a pretty plant. Don't tell the Kearns people that. And I was wondering if like if the foliage, like it's rating so high, like the foliage and the textural interest is rating so highly here that I wonder if that influences the breeding program also, or like I don't know these markets, but like, is there a market for the greenery and the texture as much as there is for the flowers themselves?
Yeah, that's actually a really great question because there's an existing market for the green seeded stems. If you go to florette.com, she calls it bubble grass. And a lot of people like just the foliage, and it might flower on the top and you still get a little flower. And there is also a market existing for the dried seeded stems. People pay anywhere from $5 to $50 just for a bunch of the dried seeded stems. But as far as the actual cut flower, no, that's what we're hoping to kind of develop, because there are existing markets for the other floral products.
Okay.
So that's an interesting point, because one of the things we look at when we're breeding for herbaceous perennials or cut flower types is their performance in the field or production trials and so forth, is how many leaves do they have and what the coverage is of the stem for leaves from an ornamental standpoint. So for a greenery harvest or something like that, that would come into play. And so, obviously part of the data that comes out of this will feed into changing or adding to our cut flower idiotype or herbaceous perennial idiotypes, so that we can, obviously maximize on what is perceptibly something important for these that we hadn't thought of.
Or something that you're already like plugging into.
Right. So good point, yeah. Couple other research projects that we'll talk about. Of course, there's a lot of them going on. So we have another Europe student this next semester. Oh, sorry, this is last spring. Sorry, I'm getting ahead of myself here. This was a Europe project that Rachel Schultz did with us, and this had to do with the measuring the style and anther length differences, because this has heterostyly and oftentimes self-incompatibility linked with it. And so she measured for some of our selections over here, which included our All-America one I'll talk about in a minute. Whenever the style and anther length were extremely tightly linked as far as being the same length, we got the highest seed set. So that's what these wide lines point to. Whereas if there was a big difference between style and anther lengths crossing between plants, then seed set was either 0 or virtually non-existent. So it appears as though, at least for the few species that we were working with, that there's still a pretty tight linkage with distyly going on. So some other ornamental commercialization selections that we've been making, just point them out to you. So this is one you've seen before. This is in the All-America selection trial in their 3-year herbaceous perennial trial. It's underway. It will finish in spring of 2024. If it wins an award, then from a vegetative product, it will have to come out on the market. And so we would need to have, say, for instance, easy ways to propagate it vegetatively. So both stock plant, the type of information that Liz is generating, is one piece of data, and then tissue culture would be an important thing, and I'll talk about that in a second. But this is what it looks like in the field. And then this past year, so like on St. Paul, we planted a huge set of them. You may have seen them. So there they are in bloom on the left there in June. And then on the right, and this is like mid to late July, they were, at the seed phase, but they had very little seed set, which is puzzling because they're just a few feet away from all the other flax there on St. Paul campus. And yet there was hardly any seed bolls on them or capsules at all. And so these all got harvested for fiber analysis. So AORI has these now for analysis in our LCCMR grant for fiber. So having a nice big clone for them to look at just for fiber will give us some great ideas. So I mean, if we have this All-America winner that's a great herbaceous perennial and also is great for fiber, hey, we win twice. So so that would be fun. Other types of products that we've been selecting. So we have this selection, which is actually in Liz's cut flower. It's cut flower number 9, is brilliant blue. So this is it in the field down in Rosemont after extreme drought and still blooming. The flowers hold on. And as you walk into the field, it just jumps out. So that's one that we're going to analyze for the flower power and bright blue color that it has. Other things that we have, so we have some white sports out of what we think is Linum peren. There on the left, and then there's an oil seed type on the right that also has a great herbaceous perennial habit to it. But this has good seed yield. So that's also another potential selection. Yes.
Is sport a term of art? Does it mean something specific, or
It's a mutation? Yeah. So it's usually a mutation in the one or more flower color loci. And oftentimes it's recessive.
Okay.
Yeah, so a sport is just, it's another term for a mutant, really, so. So we have some from, this is from Hannah's work, so of the species from USDA GRIN. So these Linum flavum were perennial, so this is year 2 growth, and we selected some that have really nice kind of bedding plant habit to them. And, you know, really, really intense gold colors, so.
And the flowers are large.
And they're huge, yeah, and it was just completely unexpected, so we're intercrossing these, we'll be sending them up for additional trials just to see what they look like, but hello, yellow. And then we happened to notice midsummer, this other one from Hannah's work, this is Linum hirsutum, nice upright stems, it's not terribly tall, but it could be, but it never dropped its petals. You know, and I hauled Liz over there one day saying, Liz, look at this, hasn't dropped any petals. And this is late in the afternoon, everything else had dropped. And it was just like, guess we better look at this one. So anyway, Liz will be looking at this next year as a potential cut flower source as well. And of course, crossing this with our other accessions would be great fun to see what we can do.
So there's genetic diversity out there.
There is, oddly enough, there's some genetic diversity. Yes, whoever heard of such a thing? And then we have a New Europe tissue culture grant for this next spring that Hazel's going to be working on, and she's going to be doing the tissue culture. So, and we'll be using our All-American selection for that. We've already got some in culture. Culture is really easily, we've got callus and shoots already, so that should be highly successful, we think. And then, of course, we do have a planting at the Science Museum of Minnesota. It's going to be replanted because of some issues there, but anyway, that's there. But that's a commercial cultivar. It's none of our rare germplasm out there. So, without further ado, Kevin, you want to sit right here?
I would like.
Space ahead there, and Kevin's going to talk about all the other important research that's been going on with perennial flax around the state. Very exciting stuff, Kevin.
All right. Well, again, I'm Kevin Betts. I work with Don and Neil on more of the agronomic type aspects of this. So we'll move from the horticultural realm to the agricultural realm. And I have a number of studies where, well, we've established flax at 3 locations around the state. In 1 to 2 acre plots. One location is Morris, Lamberton is another, and Rosemount, and of course St. Paul. And I'm looking at flax in terms of something that might be an analog to the annual flax that's currently grown. So we're planting the available varieties that there are of perennial flax, and one thing that I am finding is that there really is only one variety available of Linum perennial, and that's Apar. There's one variety available of Lewis flax, and that's Maple Grove. And Maple Grove doesn't, it seems to be, to me anyway, sort of location specific in how well it thrives. And we seem to be in a location that it doesn't thrive in very well.
Yeah.
Apar does a bit better, but I'm in looking at some of Neil and Hannah's selections. I see material in there that seems better adapted to our climate than what I'm testing here. So I'm kind of excited to try some of the newer selections that they have, and we do in fact have some of their better yielding selections in increases. And next year I'll have some idea of what sort of yields we might get off of that. I'm just prefacing all this because the yields that I'm going to show you are a little bit disappointing. Okay, but in terms of flax harvest, the difficulty comes in that the seed is small, which is not necessarily a problem. We're able to combine small seeds, but the architecture of the seed is sort of a flat wing thing. And when you're combining something, wind is one of the parameters that you adjust to get all the trash out and so forth. And you want your seed to be heavy and drop through the wind while all the trash flows away. And the flatness of the flax seed makes it catch the wind better. So you have to run it at low wind, which means your sample is less clean. So it's that type of thing that inhibits mechanical harvest. And we'd like to, I just wanted to try a few things to see if we could improve on that. But the plot management in general, we were, as I mentioned, we had 3 locations. These plots were planted in spring of 2021, and we wanted to do a conventional type production system as well as an organic type production system. The conventional one would involve, the free use of any herbicides that might be deemed necessary to keep the weeds down. The organic management would involve use of competitive crops to keep the weeds down. So for the conventional weed control, we use prowl, or in some cases that's all we use. If weeds appeared later in the season, we also did a post-emerge application of Cureton, which is clopyrrolate and MCPA. Organic weed management, we tried mainly to keep the weeds down with interseeding of cereal grains. Okay, this is a shot from Kerry Eberly of the Morris site. So to the conventional system would be to the right, and the organic system is to the left. The production in the organic was somewhat less, but actually, at least at Morris, the weed pressure was really kept under control with the competition from the cereal crops. So that was kind of interesting. Here's an early shot of our Lamberton planting. This is a conventional planting. Here's a shot of the initial seeding with the spring wheat as a nurse crop and the flax seeded between. So that's how we establish the organic plots everywhere, by just alternately seeding rows of flax and spring wheat. And that actually did a pretty good job of keeping the weeds suppressed, and flax was able to tolerate the competition from the cereal pretty well. I mean, it wasn't highly fertilized, so the wheat wasn't super big, but nevertheless, it did establish pretty well that way. In the second season, what we did was to maintain that sort of cereal competition in there, we interseeded winter rye between the flax rows. The greenery there is the flax, and this is shortly after the winter wheat was drilled in. And when we drilled in the winter wheat in the spring, it doesn't get to the huge stature that you think of when you think of winter wheat, just because it hasn't gone through a winter. So it basically only gets maybe 6 inches tall, and it just stops growing. Something like that. Okay. Well, this is another shot of our plots there. There we go. Let's move on to the harvest methods, and these are the two main techniques that I wanted to evaluate. Combining on the right, you're all familiar with. The combine on the left is one thing you're all familiar with. To the right, that's what we call a seed stripper, and it's more commonly used in native seed production. And what it basically is a flail and a reservoir for the seed collection. So if you have seed sitting up high, like you see there, the flail will chop the seed off and collect it into a reservoir in the back. The beauty of that is that you're at least with that type of growth habit, you're you're able to avoid all the green vegetation in the seed and just chop off the high setting seed. So I had sort of high hopes for that. I don't have a machine like that. This is something that I do have. It's the same idea, but more on a weed whipper type setup. But that's how it works. It has a flail that spins around, and the seed that's chopped off gets caught in that bag behind. That's a plot that's been stripped off. Okay, I should have had these are a bit out of order, but should have had a description of my treatments, but maybe that's further on. Maybe I should do that and come back. No. Okay.
I don't think you have
Okay. I lost that. but-
backward.
Oh, yeah, okay. Anyway, I had a number of treatments. One thing that assists with harvest, of course, is keeping the moisture down. And there are a number of ways to do that. The old-fashioned way of drying out a crop that's green like this would be swathing, which is basically cutting it and laying it in a row and letting it dry down for about 7 to 10 days. And once it's dried down, you can run it through the combine, and you'll have much better success than you would if you try and combine it green. So I had a couple of control treatments. One was combining at maturity without doing anything to dry the plant down. The second treatment was doing the seed stripper thing on dried vegetation. 3 would have been swathing, and then I had chemical desiccants for additional treatments. And I tried a desiccant called Defol, which is sodium chlorate, and the other one is diquat, which is diquat bromide. And those are some desiccants that are commonly used in agriculture, so they're not novel or anything like that. And they look okay. This is my stripper treatment. This is at harvest time. This is about how much greenery we were looking at when we wanted to combine the crop. So this is right before the combine went through.
How tall is that?
It's about 2 feet high, 2.5 feet high, and
It's green enough that it might muck up the combine.
exactly.
You got it.
Sorry to steal your punchline.
No, you're
Awfully green.
you're picking up what I'm laying down for sure. Okay. Anyway, this is one of the desiccation treatments. This is Defol. So you can see there's some drying effect there, which is helpful during harvest. And the diquat was even a little bit better than that. I personally favor the old-fashioned swathing. I mean, it does everything we need it to do. And in fact, I feel like in terms of shatter and so forth, that this is provided you have a efficient way of picking up the swath. This is actually pretty good in terms of shatter as well. This is it's a sort of a side thing of where the herbicides interact with the harvest of it. At Lamberton, I had a sort of a mid-season weed problem. I sprayed that with Curtail, and one thing that I didn't realize at the time was how much maturity delay occurs when you spray something with Curtail. So that's something that I but anyway, at Lamberton, one thing we noticed was that the organic side was getting dried out, and the side that had been sprayed with Curtail never seemed to get drier. And we arrived at the thought that, yeah, that's probably what it is. By spraying with Curtail, we we kept it greener, which is obviously something we don't want to do. Of course, swathing or desiccating it would get around that anyway, but. And this is one of the organic plots right before harvest. So organic at Morris especially did reasonably well. Okay, and the data is not complete, so you don't see any stats on this or anything. I've still got probably half of all my samples to go through yet. So these are the totals that I have at this point. Is that thing misaimed up there? Is that?
No, there's something in his computer that.
Oh, okay.
Makes it off,
All right, but anyway, the yield comparisons,
but it is misaimed.
yeah.
People
Um,
online can see the whole thing.
Oh, good,
So.
good. Well,
That's great.
let's
It
just,
first bites it again.
before we look at these numbers, take a look at the bottom lines. These are the meter squared checks here. So that's how much seed should actually be out there. At Lamberton, it was 255 pounds of seed per acre. Morris was 335. So you can see when you look at the numbers I have up there, it's not very good. There's a lot of harvest loss there. And there's, let's just run down the direct combine. This would be just combining it when it's physiologically mature. We didn't have to try to dry it down or anything like that. We got 130 pounds per acre of seed. Moisture was extremely high at 40% at Lamberton. This is a bit drier at Morris at 23%, but I don't know. That's probably about retrieving about 50% of the seed that I caught it. So it's not great. The best treatment I thought anyway was the swapping, which is the second one. So, at Lamberton, I got about the same amount of seed, but the moisture was cutting more than half anyway. So 16% moisture is still probably a bit wet. You'd like to see something for safety purposes, for safe storage of flax. You'd want to be probably closer to 10, probably. Morris was better. That's probably the best one I've seen so far. That's 230 pounds of seed and 10% moisture. That's getting into the range of, that's kind of what you want to see. So at least there's that one. Seed stripper was generally a failure throughout, and I don't know if there's a way to improve the performance of that or not. It is. I mean, it should be throwing the seed backwards, but it is pretty violent, and flax is kind of a shattery plant, so it maybe was throwing the seed.
Well, and too, the inflorescence of flax is not like a grass where it can be on top.
Yeah.
I mean, the bolls or capsules are buried kind of in the plant. So it's
Yeah,
hard
yeah.
necessarily to get
Yeah,
out.
so
So,
that's a good point. It wasn't like the grass that they depicted there where
Yeah.
it's a column with all this, it was kind of more of a down into the foliage a little bit. Okay, and then the lower section, we have our harvest aid desiccant treatments. Default combine is the top one there, and that clearly we reduce the moisture substantially in the harvest efficiency with the combine ones. That's pretty comparable to what we had before, but we have lower moisture. So in terms of doing what we wanted here, that was pretty effective too. I guess just as a general principle, I like the swather better just because I don't like spraying things on stuff that people potentially could be eating. But I don't know how serious that is, but that's.
Hey, Kevin, there's a couple questions.
Yeah.
One of them is, are the yield values at the moisture reported, or were they calculated to a standard moisture?
These are not, I probably will do that eventually. These are right now, after I threshed and cleaned them, I didn't really check the moisture after that. So I think they're probably pretty close to each other though, yeah.
Okay, so not coming out of the field, but a little.
No, because even coming out of the field under the best of conditions, they're still pretty dirty, in terms of. So I have to do a lot of after cleaning to get them to a point where, yeah.
Okay. And then Carmen asks, what about an actual combine stripper head as they use with small grains?
Yeah, that, do you have one, Carmen?
That you'll lend to us?
That's what he's been using. So.
I don't have one.
Okay, yeah, no, that's another thing I had in mind, but, all I have in my possession is that weed trimmer modified one. And that, I think it gets the idea across, but something that's a little larger would be nice to have.
Maybe you have to write a forever green grant.
Well, right, and
For all the projects.
I'm
Have one
sure,
to share.
unless I get it from China, I'm sure it would be like $200,000 too, but,
Don has lots of money.
yeah. But, I think I'm gonna say a few words about the herbicides. Is there any more harvest type stuff, questions?
Well, it's really interesting in terms of, just to remind everyone, these are the two varieties that are out there in the world, and none of them were selected for high yield.
Yeah,
Where do they come from?
well, the Apar, I think, was developed in South Dakota, wasn't it?
Well, by the US.
USDA.
USDA.
Yeah.
And they're,
But to maintain genetic
yeah,
framing of that, and that's the native one. right,
yeah,
To the Black Hills.
right.
They cultivate as a reference species or?
And I think the selection process was, it wasn't developed so much as just selected. They had a bunch of lines and I think they actually thought it was Lewis flax, didn't they initially? And they eventually decided it's not
Decided
Lewis
it's
flax,
Perennial,
it's
yeah.
Perennial.
But the point I'm making is this is the base.
Yeah, so
That
they,
you guys could look pretty good, pretty fast.
Right. Good for us.
So I guess that's what I'm asking. Do you have any estimates of some of your new lines that you're bulking up to get an idea of the yield potential of those in comparison to these two?
Well, we do, we don't have any recent calculations. We have last year's.
I know, but
that were
is it, you're at least double?
oftentimes double or triple. We had some that were
Yeah,
very high.
yeah, right.
and one thing I should say though. For these yields, this year was bone dry too. And the fact sheet for these says they should yield about 500, 600 pounds per acre. So we're, they're not.
But the point is, some of your lines could be
fabulously high.
1,500.
Correct.
Yeah, right.
Yeah.
Yeah.
And of course, these are not irrigated, so,
No,
so they were dry. So, and of course, this also leads into our foreshadows, our current FGI grant that we have in on the need to select for non-shattering because,
right.
well, no matter when you go out there, you've got shattering going on, and so we're losing untold numbers from shattering. So
And we do know that non-shattering trait is out there.
yes,
Right.
How much earlier can you swap them than if you wanted to do another method of harvesting them?
How much earlier?
Yeah, in the season, because like you get some
Oh.
dry out of the swap.
Well. Yeah, one of the beauties of swathing is you can cut something that's still kind of green, and then in that way you can avoid a lot of shattering just because you could, cut it before it's much, well, you want it to be physiologically mature, but. This was, I don't know, this stuff was done in mid-August probably, and
we were a few weeks late, yeah.
Flex is a little different in that it doesn't really dry down ever. So it's almost like you have this huge harvest window where it's all kind of the same. You get always have immature seed and all the way to shattering seed kind of in a big long.
Because that's like a domestication trait.
Right.
Everything all right at once.
Yeah.
Well, it's a stay green crop
you know, it
from
is.
April to snow cover.
What's the typical, annual flax yield?
Well, it's probably more like 1,800 pounds, so we're substantially off of that.
Carmen, what's your yields in your farm of your yellow flax?
About 30 bushel.
Yeah, it's gonna be anywhere from 15 to 25 year to year. Bushels, that's 56-pound bushels.
Yeah, okay. I was thinking 1,800, that'd be about 30 bushels, so it's less than that, I suppose, yeah.
Yep.
How many
Right.
years would they productive?
Well, that's one thing what I want to say. Two, I think I could safely say two. I think, given the right selection, it might be more than that.
We have some that we've harvested over year 3 and 4, so.
It's all part of the breeding program.
Right.
I've tried growing it in my garden and rarely get it more than a year at a time.
Well,
Is it the production or the plant? I'm not sure where I got the seed. It's probably still.
Could be the genetics.
There was an exchange on the chat. Carmen asked if it's boll shattering or the seed shattering from crushed bolls. And Elizabeth responded that the seed boll shatters or opens and the seeds fall out.
Yeah,
I don't know.
Yeah, I wasn't really correct.
Yep, that's right. But we should speed on here because we're over time already.
Yeah, I could just, okay, this is organic, so you see, you don't have the option of using desiccants here, but I mean, the swather would be a reasonable way to go on this, and you see, sort of the same type of results. The top line would be the direct combine, and organic plants tend to be drier out of the gate too, so that was kind of a plus in terms of harvest. The yields were less, of course. But again, it was a dry year and they have additional competition, being the way we were growing them with the cereals, they have additional competition for moisture too. So the yields in terms of what we had was not awful. So okay, going forward, we'll do kind of the same thing as we did this year again, if we have a reasonable stand. I'd like to add some fertility trials, look at some of the improved lines that we have planted. I'm interested to see what the yields of those will be. I'd like to see some very variable organic type stuff for flax production too. Okay, I'm going to run through this kind of quick. We're trying to identify herbicides that would be useful for perennial flax. And IR4 is a labeling process for getting some of these products available for newer crops, and that's what we're working up to here. This is materials and methods. What we really we'll just move up to what we really want to know here. These are pre-emerge herbicides that were suitable for perennial flax. The best one in terms of tolerance was probably Prowl. But there were a number that you could apply pre-emerge and get reasonably good stands. Herbicides, okay. Post herbicides was a little tougher to find here. We had a couple that were really well tolerated. The Stinger or clopyralid was really well tolerated. That's a good weed product for controlling composite weeds. So it's kind of important for thistles and ragweed and stuff like that, but there's a lot of common weeds that it won't get. So clopyralid is one that gets most of the weeds we're concerned about, but in terms of tolerance, it was okay, but it did delay maturity and that sort of thing. Everything I have listed here is probably something you would consider using. For grass weed control, we had the clethodim and the select and the assure 2, and those both were well tolerated. And I think this is my summary here, but these are sort of in the order of how well tolerated they are. You had the trapline, prowl, dual, and Spartan. For grasses, you had assure and select. For just general broadleaf weeds, stinger, accent, raptor, curtail, and express. It's those, everything I have up there would be something you would consider if you had a weed problem. So
Now the idea would be to work with IR4
yeah,
and see if any of the companies would have an interest.
Right.
Right, and then set out and have, working with them to develop a strategy of evaluation that would match up with the potential companies.
right. So anyway, that's, now we know something that's, what's worth wasting our time pursuing, pursuing.
Yeah, so we have to, start those discussions.
Yeah.
With the IR4.
Okay.
But see, and that's all done at what, Oregon State, right? Or isn't that where IR4 is headquartered?
No, North
Is it-
Carolina now. We
North
like
Carolina.
yours to North Carolina.
Oh, okay, all right.
Yeah.
I wasn't aware of that. All right, good. Just some other quick trials. We'll just jump through these fast because we're out of time. We know that. So we have trials.
We go to 1:30.
Okay. But we still have a slides yet to go. So just some other trials in the breeding program that are ongoing, and these are in irrigated plots with pre-emergence and tilling and so forth going on. So they're kind of under ideal situations rather than drought stress or anything like that. But we have trials at Rosemont, St. Paul, Morris, and Grand Rapids. So 14 top selections out of the breeding program, both agronomic and ornamental, so cut flower, oilseed, herbaceous perennial types, etc. And of course, we're looking at winter survival, overall growth, and obviously yield for oilseed. And so just some examples. And you can see, like, for instance, at Rosemont, we've got a huge range in mean number of grams per plant. This is just the first harvest, July. So it doesn't have the October harvest in there. But you can see the big differences between the sites, which genetic expression at various locations. Imagine that. So there's Hannah hauling bags away there from this fall. And then we have a couple of elite trials now of our high yielding oilseed types at Rosemont. So one set planted in 2021. So we had 2-year harvest this year that Kevin was harvesting. And then we planted another set this year. So we'll have a year 2 harvest next year. And these are just some examples of the plots that are there. And of course, we have comps of Appar and Maple Grove again. And this is just overall. So we get about 5 grams or so per plant on these higher yielding lines. And sorry, I didn't put these in pounds per acre, but it's comparable to what Kevin's been finding in some of the other studies, or higher. So we have the LCCMR grant that's now in about month 5. We started the 1st of July. So we're not going to present any of the results from that. But suffice it to say that, next year we'll have obviously lots of things to talk about from a whole range of angles for it. And so the activities, not objectives, activities in LCCMR, we're looking at perennial flax for pollinator services. So basically ecosystem services, since we had noticed that flax bloom early in the season, and we have flax blooming in November when most everything else is dead. So after a freeze, it'll still reflower. And so this is the team of people working on it, and the objectives that they're looking at. And initial studies of just looking at pollinator visitation in St. Paul and Rosemont showed that indeed honeybees, bumblebees, and other types of pollinators we're visiting, both for feeding as well as for pollinating. But of course, additional studies in more in-depth will happen next year, along with looking at the nectar and the pollen constituents, et cetera, as far as, are these feeding the bees, et cetera, and can we end up with expecting to come up with products, could we have honey that's flax honey that might be high in nutraceuticals, omega-3s or something like
And
that.
blue.
And blue, of course, we'll add some dye to it or something, so it'd be blue. So you never know what could come with it. And so then AORI is going to look at the yield, the economic data and so forth from the pollen and honey sources and so forth to come up with some business models for that. So stay tuned on that for sure. Activity 2 is looking at the oil seed, because for all of our oil seed types, all that we're saying really is they have a phenotype that we're selecting that makes them amenable to mechanical harvesting, but that's all we know. We don't know what the oil seed constituents are or anything, since we haven't had funding for it. So that's what's going to happen with that. And so Pam and her team, Anastasia is a new MS student there with Pam in the Plant Protein Innovation Center. And then Ori is going to be doing a lot of comparable work with it too, especially Michael at AORI to be able to start analyzing all of our elite samples that we have that are high yielding. And so those are the kinds of objectives they're going to have to look at. And this of course ties in with Kevin's work with mechanical harvesting and so forth, to look at yield and then come up with all of the protein and other component constituents of the oil seed. And then AORI will use that data and so forth to enhance harvestable products and create business development models for us. So, and then looking at other kind of value added processes, in particular fiber. So this is mainly AURI that's going to be working with all this. And this is not perennial flax on the right. That just happens to be annual flax that's harvested for fiber. You can see how tall it is. So ours are tall, but they're not that tall. So we may have, shorter length to the fibers. And what does that mean? And annual fiber, when it's harvested, they pull up the plants. And so with perennial plants, we don't want to do that. We'll have to cut them off. And so we're going to lose maybe up to a foot of fiber length when we do that. And so what does that mean? We don't know, from using it for linen or any other type of potential uses for the fiber. And of course, we don't know what the tensile strength is and what fiber types, et cetera, it is, and if it differs from annual flax, or are all the perennial species different from each other, et cetera. So all that kind of information will be really valuable components for us to feed into the breeding program and make selections further down the road. And obviously, there's lots of people that are interested in the culinary use of it. And so, because we've already had requests of like, can we have flaxseed to cook with and stuff? And it's like, well, you can, but we haven't tested it to see if there's any poison in it or whatever, or if it has anything of value. So, or the flavor components, et cetera. So, so cooking and baking with flaxseed, of course, would be very important. But that's down the road in a year or two here under this activity. And then last but not least is our kind of extension, education and outreach that AORI and FGI will pioneer for that. And so it kind of folds in with AURI's connects that there already connects that they have. And so we'll plan on having some of those and having 2 perennial flax field days, either starting next year, the week or the year after, and we've never had a perennial flax field day yet. So this will be kind of our little swan song there in that round to solicit for interest amongst growers across the whole range of potential product lines, you know, for oil seed, for pollinator activity, for fiber, for cut flower, herbaceous ornamentals, et cetera, just to see, engage what the interest is and how we can then push product development and so forth for perennial flax. And then I mentioned that we have, you know, our Forever Green Initiative pending grant in there, and in this grant is where, you know, we're going to be addressing this non-shattering selection to try to increase your yield, because that's really the main thing, because we've guesstimated in our breeding programs that we have 33% or more yield loss due to shattering. Of course, it's sometimes genotype specific or species specific. So we range about 3.8 SPC or seeds per capsule. And the whole range across the program is like up to 7.6, but non-shattering could potentially increase our yield by 2x or more. And so in addition to mechanical harvesting, picking the best one, and desiccants, et cetera, coupling that with the breeding, that we might be able to then approach annual flax. Maybe we'll surpass it, who knows, because we can harvest it twice a year. So it's possible that perhaps we'll be able to do that. So that's the goal there. And obviously the weed management for IR4 registration comes into this as well. And of course, Kevin's already talked about that a bit. And then the other was having Carrie Eberly up at Morris working with us with additional pollinator studies to complement the LCCMR grant. And are you online, Carrie? I haven't looked to see.
She has been.
She
I'm not
has.
sure if she had to drop off or not.
Or
I
she's still
am
there.
here, but I
Oh, you are,
noticed.
good.
Yeah, I am.
If you want to talk about this one and the next one, go ahead.
Sure. I guess just real quick, you know, these perennial systems have a lot of potential value for our agroecosystem services, one of which is potentially the pollinators and insect value. So this would be complementary to what the LCCMR team is doing and really focused on identifying that floral phenology of elite oilseed germplasm and see if we can identify lines that have more pollinator values than others and correlate that with their yield potential. One of the issues with annual flax is those flowers drop by about 11 a.m. They're only producing nectar for a couple hours in the morning. The total nectar production on a per acre basis is very small, as is the total pollen production because of that time frame and floral density. And so as Neil's team keeps working on breeding these lines, you know, having something perennial on the landscape that's a mass flowering crop, would love to be able to actually build in those traits that are going to be beneficial to our pollinators. So if you go to the next slide, this is just some preliminary pollinator visitation from last summer, and this is on the APAR variety in Morris. So it's insect counts per minute at on 6:17 at 7 a.m., 10 a.m. and 12 p.m. and then 6:22 at 8 a.m. and 10 a.m. So what you see is how quickly that visitation drops as we move later into the day. So by noon, we've lost pretty much all visitation on those flowers. So trying to identify varieties that are going to extend that flowering time and hopefully extend our pollinator visitation is something that I'd like to try and do with this objective. So that's all.
Great. Thanks, Carrie. Any questions from the audience at large for anybody?
There's a couple on there. Les Everett asked about yield decline. Does it Does it decline or does it stay somewhat stable over the years? I'm guessing he's referring to oilseed field.
Yeah, I think it stays stable. Yeah, I know what he's referring to with the currents that you get that drop off over the years. I don't think that happens here. But it doesn't last as long as currents either, I don't think. But,
Yeah, I don't think so either. Yeah. Although it does, tend to recede with shattering, so, in a commercial field, you might not notice it as much, but who knows?
Are those, is that receding viable? Because sometimes.
Quite viable.
Because sometimes the ferns are so good at rhizomatous growth that sometimes this shattered seeds get these wimpy little seedlings that. Don't.
No, they're quite vigorous, and in fact, it helps with weed control and stand establishment for the next year or so.
Mm.
Yeah.
Yeah, it looks like a really dense canopy.
Carmen asked if it's indeterminate, the plant, perennial flax, if it's indeterminate.
yeah, yes, it is. What we're working with, I think there's a few that we've seen that are determinate, but for the most part, they are, yeah.
So just thinking that through, if it's indeterminate flowers all summer long, is the ultimate system gonna be something like you swap it, harvest it at a certain point of the year where it's kind of made the amount of yield it can carry, and then let it do it again and take.
Yeah,
take a
that-
second harvest?
That's the
Yeah.
idea.
Yeah. And of course, when you're harvesting them, you're getting a whole range of development, which can help that with indeterminate, but usually around July. Mid to late July or so is kind of when you see the oil seed, they kind of stop for a while. I mean, there's a few blooms, but it's like, okay, this is a good time to harvest, and then October-ish, late September-ish, we can do the second harvest.
And have you seen them being relatively equal between the two, or does it?
Oh, the harvest?
Yeah,
Oh, it varies. Yeah, it can be less in the fall and highest in the summer, or in some lines, a lot of them, or other cases, it's can be high in the fall and lower in the summer, so.
Yeah.
Genetics at
Yeah,
work
but
again.
the other concern about the late harvest is you don't want to take up too much vegetation and hurt the overwintering capacity of it. And that's
Right.
why I kind of like the stripper idea, because I was hoping you could just, very, surgically top off the stuff, and leave
Yeah.
a lot of leaves,
Leave more of the plant there for over winter. And these oftentimes stay green during the winter.
Yeah,
They're below the snow cover, so, yeah. So they're almost evergreen.
So Neil. I can see how, the floriculture components are gonna move faster than the oil. So. From an oil fiber perspective. To get that first real variety out there. Can you do it? Can you do it within 5 years?
Well, I would say it's gonna depend upon, how long it takes us to identify the best lines for oil seed, for instance, and the various
But
qualities.
in terms of
and
your
then
timeline, what are you thinking?
In the timeline, 5 years. We'd be pushed, I'd
Yeah.
say, for sure. I mean, we'd certainly try, but it might be a little longer than that, I would guess, more like 7 perhaps, yeah.
Well,
Kevin can never retire, I can't retire, and
Well,
Don can't retire, so we'll just have to work 48/7 instead of 24/7.
if Kevin retires, I'm gone, man.
Right, yeah, I'm leaving too.
You don't know, if I retire, the pace might increase, I don't know. I've probably been dragging you down for 20 years.
I,
Oh, I don't
the
know.
evidence doesn't support you.
Your seed cleaning skill is much better than other things we've done, so.
I have one more question about it being indeterminate. If it's indeterminate, does that mean it's harder to choose when to harvest it?
Or easier,
Or easy.
because there really is no perfect time.
Yeah.
It's. There's just like a huge window and just do it anytime because it's.
Yeah. Not gonna matter, it's keeps blooming, so.
the
Do
farmer
you have an
can-
estimate of how much, when you harvest it, how much it comes off is immature seed that just can't mature itself?
Oh, we looked at that a few years ago and I can't remember what the ratios were. Do you remember? We have the
Does it
data.
seem like a lot?
Probably, let's see, it could be up to like a third, if I remember right.
It might be a lot, although after the cleaning, you can't really tell how much there was because the light. Immature seed is light, so any wind cleaning process is gonna send it bye-bye anyway, so.
We examined like 10 capsules from a whole range of selections and then did actual counts within the capsules of fully developed versus underdeveloped. But I just don't remember what the percents were.
Well, Neil and team. Thank you very much for the great update and great to see the success in LCCMR and that new support and exciting. And I mean now appears to me we have a great platform for moving forward, getting everything sorted out in terms of the variation in the species that we have and are available and what can be done with them. So thank you very much for the update.
You bet. Yeah. Come see our fields.
Yeah.
They're usually blue.
If you get there in the morning.
If you get there in the morning, right?
Thank you. Thank you, everybody online for sticking with us.
We can close. Carmen did have one more suggestion or question about.
All right,
If we
Carmen,
had-
okay, Carmen.
If we had a stripper head, could you harvest more than 2 times?
More than two, I don't know, that seems like a big question, I don't know.
Carmen, this is done. Yeah, you could. You could do that.
You could do that, yeah. Don't worry about it. I'm
Just be doing it for fun, but.
Maybe in southern Illinois rather than Minnesota. I don't know.
okay.
Well, it looks like to me, as I've watched it over the years, two,
Two is possible,
looks like it's
Three
possible.
would be, unless we get lines that are super,
Yeah,
have great recovery.
yeah,
Right. It takes them a while to regrow, send out the shoots, flower, set the capsules, so, because you're doing, if you're doing a complete cutoff, so.
they come back very fast.
But they do, but still. takes time.
Okay,
All right,
Carmen, get back to work.
Ah.
So it's
All right, bye-bye. Thanks, everybody.